rational functions, and in particular, vertical asymptotes. Okay, well, what is a rational function? Well, it's important to note that rational functions themselves are not polynomials, but they are ratios of polynomials, as in when you have a polynomial p of x over another polynomial q of x. That would be an example where, say, your rational function f of x equals a polynomial in the numerator and a polynomial in the denominator. Okay, well, what about vertical asymptotes? Well, let's take a look. Here we have the function, our toolkit function, of x equals 1 over x. And here at x equals 0, we have a vertical asymptote. Now, the informal definition of a vertical asymptote is a vertical line that your function approaches but never crosses. Okay, so that comes from here, from section 1.2, if you'll recall. You can't have a 0 in your denominator. So to find a vertical asymptote, you would set your denominator equal to 0, and then that ends up being your vertical asymptote. So for example, if we had a function that's a shift, a horizontal shift of our reciprocal function, we would set this equal to 0, and we would find out that x equals 3 is our vertical asymptote. With asymptotes, so we talked about the informal definition. So here's a more formal definition, but what asymptotes are particularly interested in is behaviors at infinity and negative infinity. For vertical asymptotes, as you approach that value of x for your vertical asymptote, your f of x will approach infinity or negative infinity. And then for horizontal asymptotes, you're interested in x, as x approaches negative infinity and x approaches infinity, what happens to your graph. That will determine the horizontal asymptote. It's important to note that you can have horizontal asymptotes that, for example, look like that, where you have a function with a horizontal asymptote that looks like that, where it approaches this horizontal asymptote, your function approaches this horizontal asymptote as x approaches infinity, for example, but it's never going to cross that asymptote. But it's okay, actually, in some quote-unquote earlier value if it does cross a horizontal asymptote, which is different from a vertical asymptote. Vertical asymptotes never cross. Okay, let's look at a problem from the study guide. So this is about determining the domain of this rational function. Well, this relates back to section 1.2, domain and range, and it also ties in with vertical asymptotes. So we're looking where this denominator is undefined. So we set it equal to 0. And then in this case we can factor, as in what? We have an x times an x, and then it will also be constants here, and they will be two numbers that multiply to -3 and add to -2. So you have x minus 3, x plus 1, and 0. So you have zeros, or really in our case you have a vertical asymptote at x equals 3 and 1 at x equals negative 1. So graph, if you're drawing asymptotes, negative 1 and 3, you have asymptotes like that. So your domain in interval notation would be from negative infinity to negative 1, not included, union, the interval from negative 1 to 3, union from 3 to infinity. Okay. And those are the vertical asymptotes where our domain is not defined.